This is my first video lesson on Unit 7, Energy. In this lesson, we'll be analyzing energy, heat, and temperature. So go to page 2 in the class packet. You can download the class packet from my website. Learning target. At the end of the lesson, I'll be able to analyze energy, heat, and temperature. Homework will be number 1, which will be a junior pod based off this lesson. Energy is defined as the ability to do work or produce heat. There are two types of energy: potential, which is stored energy, and kinetic, which is energy in motion. Both of them follow the law of conservation of energy, which is the energy cannot be created or destroyed, but can be transferred or converted. There are 3 units of energy that you must know for the regions. The first one is the joule, which is found on table D on your reference table. The next one is the lowercase calorie, and the other one is the uppercase calorie. So how are these 3 units of energy related to each other? 4.18 joules is equal to 1 lowercase calorie. The other unit that you must know is kilojoule. 1000 joules is 1 kilojoule. For the lowercase calorie, there is a kilocalorie, in which 1000 lowercase calorie is 1 kilocalorie. To compare the lowercase calorie with the uppercase calorie, 1000 lowercase calorie is 1 uppercase calorie. Now we're going to match the type of energy with the definition in the picture. The first one is the energy stored in the nuclei of an atom. That is nuclear energy. The kinetic energy, such as gamma rays, X-rays, ultraviolet, visible light, infrared radiation, microwaves, and radio waves, that is electromagnetic. The energy which is possessed by an object due to its motion or due to its position, it can be either potential or kinetic or both. This is mechanical energy. The kinetic energy associated with heat and the particle movement it causes, this is thermal energy. The stored energy found in the bonds between atoms, this is chemical energy. Kinetic energy associated with moving electron, this is electrical energy. Nuclear and chemical energy is considered potential. Thermal, electromagnetic, and electrical is considered kinetic energy. Mechanical energy can be considered potential or kinetic. Learning check number 1. Which form of energy is associated with random motion of particles in a sample of water? Pause the video and resume once completed. So the answer is choice 4, thermal energy. What is temperature and heat? Take a moment to read the paragraph on page 3 on my packet. Temperature is the measure of the average kinetic energy, the speed of the particles. The units of temperature is Celsius or Kelvin. Heat, on the other hand, is the thermal energy transfer from one object to another. The unit of heat is joule or calorie. So as you can see, temperature and heat are 2 different things. There are 2 units of temperature in the metric system, Celsius and Kelvin. To convert between them, you have to use the equation on table T on your reference table. Kelvin is equal to Celsius plus 273. Kelvin is known as the absolute scale. Absolute 0 means 0 Kelvin, which is the lowest possible temperature the substance can be. Learning check number 1. The temperature 30 Kelvin expressed in degrees Celsius is what? Pause the video and resume once completed. The answer is choice 2. You can solve this using the equation on table T on your reference table. Learning check number 2. Which statement defines the temperature of a sample of matter? Pause the video and resume once completed. The answer is choice 4. Temperature is the measure of the average kinetic energy of the particles. Here are a bunch of questions to help you understand heat and temperature. Question 1. Compare hot and cold in terms of heat. Something that is hot has more heat than something that is cold. Question 2. Describe how does an object becomes cold. Does cold transfer? When an object loses heat, it becomes cold. Cold does not transfer. Question 3. Do cold objects contain heat? For example, ice. Yes, because atoms are moving even in ice. Question number 4. Does heat always rises? The answer is no. It's the hot air that rises. Heat moves by radiation, conduction, and convection. Question number 5. Does adding heat always increases the temperature? The answer is no. For example, a phase change. We will explain why later on in the unit. Question 6. Can the temperature of ice, water in a solid state, 0 degrees Celsius, be lowered? The answer is yes, because heat can still be removed from the molecules. Question 7. Is boiling point the highest temperature a substance can reach? No, because a gas can be heated. Question 8. Is temperature a distinct property of a substance? For example, metal is naturally cooler than plastic. The answer is no. Different substances can be the same temperature. Question 9. Are objects that keep things warm, sweater, mittens, and blankets, sources of heat? The answer is no. They keep you warm by trapping heat. Question 10. Which has more heat energy, a burning match or a giant ice sculpture, and why? I want you to watch a video about this. Click the link in the descriptions and then resume this video after you watched it. So the answer is because the statue has more molecules. So the sum of the energy in the statue is much greater than the match. The match has a higher temperature, but the statue has more heat. So here's a summary slide of what we talked about. Temperature is the measure of the average kinetic energy. The unit is Celsius or Kelvin. Temperature does not depend on the size or the type of object. Temperature can be measured directly with a thermometer. Heat, on the other hand, is the thermal energy transferred from one object to another. The unit for heat is joule or calorie. Heat is the total energy molecular motion in the object. Heat does depend on the size or the type of object. Heat cannot be measured directly. We will calculate the heat using the table T equations. Learning check number 3. The particles in which samples of LiCl have the same average kinetic energy as the particles in a 2-mole sample of H2O at 25 degrees Celsius. Pause the video and resume once completed. So the key word is same average kinetic energy, which means the same temperature. The answer is choice 3 because it has the same temperature. Here are some more analogies to help you understand heat versus temperature. You have one big cup and one small cup of hot water. The temperature of each cup is initially at 100 degrees Celsius. Which cup will reach room temperature first, or they'll reach it at the same time? The small cup will reach room temperature first because it has less heat. It has less molecules at 100 degrees Celsius than the big cup. Second question. Which cup has more heat initially at 100 degrees Celsius? That will be the big cup because it has more molecules. Here's another analogy. You have one small and one big ice cube. It's 100% pure water. Which ice cube will melt first? Assume that the same amount of heat is applied to each ice cube. The answer is the small ice cube. Which ice cube takes more heat to melt completely? That'll be the big ice cube because it has more molecules, it has more attractive forces to break, so more heat is required. Here we have two containers of water. Which has a higher temperature? They both have the same temperature. They both 25 degrees Celsius. Which has a higher average kinetic energy? The answer, they have the same. Because average kinetic energy means temperature. So they both have the same temperature, therefore they both have the same average kinetic energy. Which has more heat? It will be container B because it has more water molecules than container A at the same temperature. Which has the highest average kinetic energy? So average kinetic energy means temperature, so which has the highest temperature? That will be container A. On the Regents exam, They will not ask scenarios about which has more heat when the temperature is different. Usually, one of the variables will be the same. Learning check number 4, the average kinetic energy of the water molecules is the greatest in which of these samples? Pause the video and resume once completed. So the average kinetic energy is the temperature. Which has the greatest temperature? That will be choice 2. So this concludes the video lesson for today. Remember to do the Junipod homework.